The following content is supported by victoris.org.
So they ask for two integers from the user, two floats, right? You check if both of them are positive. Okay, we can actually make use of the else over here, because you realize that if both of them are positive, then both are positive, right? You print both of them. Else, yeah. So that's where we can use the power of yeah. It takes a bit of practice to put them together. You could have very well written a lot of other if statements, but then that'll be a bit more complicated. Yeah. Yep, you're correct. Okay, great. Yeah. So you can run it to test it, and then we can move on to Q6.
Oh, okay.
Make sense?
Yeah.
Does it work?
Yeah.
Yeah, awesome. So this is your testing your if, elif. You know, just now we had if, elif, 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 elif. You check multiple conditions one by one. Yeah. Okay, so we want to compare if the drink that the user inputted is equals to Milo, right?
Okay.
Remember that now it's looking for a variable called Milo. We want to compare with the string Milo. Yes, that's right. So we have a else is catching all other cases. Yeah. Awesome. So you can test your code out and see your hard work come to fruition. Make sense?
Okay.
Yeah. Lastly, Q7. Now, just now, if either one of them was not positive, then I'll say, I just want to say there's an else that catches that case, right? But what if I want to tell the user exactly which number is? So for example, 1 and 4 both are positive, but -2 and 4, I tell them the first number is not positive. -2 is not positive. Otherwise, I tell them -9 is 1 and -9. I tell them the second number -9 is not positive. Do you think you can piece together the logic? So you first need to ask them for two numbers. So let's start with that first. Then you can print out the two numbers if you are comfortable with that. Okay, so now let's remember that both are positive case. Right, so you can try that.
Let me see. N is for if
both of them are
both
true,
is-
then the n is true. If that one is true and that one is true. Think about it that way. Okay, so this is why we. Okay, I get where you're trying to go with it. Okay, there are a few ways to go about this. Usually students come up with all kinds of complicated and jumbled ways to do it. So if maybe I can show you what. So if number 1 and number 2 is greater than 0, both of them are greater than 0, then both are positive, right? Then what is the second case? If number 1 is greater than 0 and number 2 is less than 0, does it make sense? Then what do you want to type? You want to tell them that whatever the user inputted first, right? In this case, let's say -2 goes into number 1.
Oh.
Yeah.
Okay.
So this way you can catch exactly which number was negative. There are a lot of interesting points to be raised about this question. I'll show you more later. And then the last case would be if you can, else would catch them.
If else. Oh, is it?
Because if all of these are false, right, then one can actually prove that not quite, both are
Not positive.
not positive, yeah. And don't forget the quotes so that and closing quote. Okay, great. So let's run it and try the code against different cases. Make sense? So this case, which line was run over here exactly?
The second number is negative one.
Yeah, correct. So it was line 8. line 6. Line 6 was run over here. Okay, if we run, let's say run with both of them are positive, both are positive. If both are negative, then which line is the one that's run?
Both are not positive.
Exactly, is this one. So okay, now I'm going to do something that seems a bit confusing. I'm actually going to delete this one and delete this one, and I argue that logically it's still the same. It's because you notice something with the order of these conditionals, right? If number 1 was positive, if number 1 is positive and number 2 is positive, then both are positive, right? Just now I had and number 2 is less than 0, but actually that's redundant because if number 2 was if number 2 was less than 0, if number 2 was greater than 0, right, then this conditional is actually going to happen first. So it's going to ignore this one anyway. And likewise for this one, this one needs to be number 2 greater than 0. So if number 2 is greater than 0, so it's like this one, if number 1 is greater than 0 and number 2 is greater than 0, then this one will run anyway.
Okay, got it.
But if this one didn't run, that means that if this one was false, right, and then this one is true, then that must imply that this one is false. And likewise for this. Okay, so that's nice. So now you can test that it works exactly the same. Discounting the fact that if we type 0, let's ignore the case where we type 0 lah, because 0 is neither positive or negative. Okay, and then now let's try something funny. Okay, so sometimes I have students come to me and they write something like that. So they just swap the order of the conditionals around. So if number 1 is greater than 0, number 2 is negative. But does it work? If I run this, let's try it, okay? Let's try the case where both of them are positive. 1 and 2, both of them positive, right? I should see line 8, right? But it says, 2 is what happened over here. Because I brought that top conditional down, right? This conditional is true because 1 is greater than 0 ma, right? And it fell into here, and then since it run this one, it ignored the rest already. So that's where the order of the conditionals actually matter, where like that I had to be careful with the order. Yeah. And actually in lesson 4 we learn some coding question, interview question, where this kind of order of the order of the numbers actually mattered to the extent that apparently 95% of coding interviewees fail that question because this order of conditionals trick them. Yeah. So actually with conditionals is where we see, I told you that coding is about logic, right? So with conditionals we start to see where this logic comes into play, where things like that start to be harder, not so easy anymore. Yeah. Okay, so if not, then let's start making the website. So we can extend the website that we made previously. Can still use the BMI calculator, just that now we want to add a feature that tells the user if they are overweight, underweight, or whatever. Okay, so BMI calculator app pro. Okay, so let's extend the previous BMI calculator we had to BMI calculator pro, where we want to add an additional feature that tells the user if they are underweight, overweight, or whatever. Okay, so you can hop over to anvil.works. Let's go back to your BMI calculator. The previous code we had was this, right? So let's just add a new message text view. So we go back to the same. You want to follow along? And we add a new label below. And we name it label underscore message. This will tell the user what class they fall within.
Okay.
So it's because, yeah, so this is the class for the wait, so you add in the following code. So same code, right? Go back to the same code over here. Just that after your display of the BMI, you write if BMI is
Okay.
okay, we're ready, you press run and it should work as intended.
Yeah.
Okay, so if your BMI is less than, so let's take a look at, so depending on your BMI, they'll tell you whether you're underweight, or let's say your BMI was a lot, then you are overweight. Okay, so let's take a look at the logic over here, because it's a bit, we see that, we first check whether like that, right? Can I switch the order of this up here? Does it work the same if I do like that? If I swap the order of, just now I check 18.5 first, right? Then I check 24.9. If I swap the order around, I check 24.9 first, then I check 18.5. Would that
No.
make sense? Why not?
Because the
top one.
yeah, the top one will override the bottom.
Exactly. This one, if this was true, then this is
Also true.
no, this not really. If BMI was less than, if this bottom one was true, then the top one is true also.
Yeah.
So the bottom one would never happen.
Yeah.
Yeah, so the order matters. We need to do the most. So in general, when you have a bunch of elif chaining conditionals, you need to put the most restrictive one on top, then the second most restrictive, third most restrictive, and so on.
Mm.
Yeah, so that you won't have a case where you miss out on one of them. Okay, so with that we just upgraded our BMI calculator, and
Yay.
yeah, so yeah, if not, that's all for this lesson. So so what's the key takeaway from these two lessons is that we learn these logical building blocks, right? And these are, we learned two logical building blocks so far. There's around two or three more, and with those actually form the basic like coding knowledge, and it's more after that, right? It's more of how you piece these logical building blocks together. Like you can build a lot of things from there actually. So it's like Lego. You learn a few pieces. Now you learn by like the 2x2 pieces. Then you learn the 2x3 pieces. Next lesson we learn the 2x4, and along the way you learn more pieces. Actually, with these you can build really big programs already. Yeah. And that's the main challenge, putting together these logical building blocks. And from here, from these, once you get a basic logic there, it's actually very easy to learn a lot of things by yourself. So they say self-learn coding, right? But actually the hardest part of self-learning coding is understanding the logic, because you can watch a lot of YouTube videos, this being one of them, but like unless you do it yourself or you have someone to help you, most people struggle to understand the logic part of it. Yeah, and from there you can actually, it's basically like runway. Then after you reach a certain momentum, right, you can fly by yourself. And from there, actually a lot of coders, they Google things by themselves. So anything they don't know how to do, they Google, they read the logic, they understand, then they learn. Yeah. So yeah, and it's also very easy to transition to new languages. Like you hear some of the YouTube videos, they say this coding prodigy knows 18 languages. Actually, after you learn the logical building blocks, right, I think you can also actually pick up 18 languages in maybe a month. Yeah, like the logic stays the same across all programs. It's just the way you write if else, it differs. Yeah, okay. So if not, thanks for attending the podcast. Thanks to the viewer, and I will see you next time.